Hello everyone, today we'll be doing past paper practice questions of circuit properties for all levels. So let's begin. Question number 1 is taken from May-June 2022 paper. It says B, D, E, F, and G are points on the circumference of a circle center O. AC is a tangent, as can be seen in the diagram as well. AC is a tangent to the circle at B, and angle DFG equals 75 degrees, and angle ABG equals 48 degrees. So we have to first of all figure out what angle DEG would be equals to. Let's see where this angle DEG is. DEG, this angle right here, is what we have to figure out. All right, this is pretty simple. We just have to see where this DEG angle is coming from. This angle is coming from point G on the circumference and point D from the circumference. Or in other words, it's coming from this arc right here. Let's see if this same arc is making some other angle at the circumference. And yep, the 75 is also coming from the same arc. And we know the property that says that angles at this that are made by the same arc or angles in the same segment are equal. So DEG would be equals to 75 degrees. The reason being that these are angles in the same segment or angles made by same arc, whatever you want to say. Next up, we have to find angle DOG. Angle DOG is right here, angle at the center. And if you see, this angle at the center is also coming from that same arc that is making two of those angles at the circumference. So we know that angle at the center is always twice the angle on the circumference. So 2 times 75 would be DOG angle, and the reason being angle at center is twice the angle at circumference. Okay, so 2 times 75, the answer is 150. Next up, we have to figure out DBC angle. DBC angle. DBC angle. It's right here. Let's use some other color maybe. Okay, it's right here, DBC angle. Now for that, what we could be doing is, alright, so for that what we could be doing is let's first figure out this angle, and we know ABC is a straight line. So one way of finding this angle could be that if ABC is a straight line, we figure out this angle, subtract it from 180 along with 48 degrees, we'd get to know what this angle would be. So let's figure out what angle DBG would be. Angle DBG would be equals to, and how I'm working out angle DBG, by the way, is I'm looking at the 4 vertices that are lying on the circumference. So what I'm looking at is that DBFG or DBGF is a cyclic quadrilateral, and hence the opposite angles would be supplementary. So angle DBG, sorry, I changed the color. Okay, angle DBG would be equals to 180 degrees minus 75 degrees, because this angle is opposite to this angle. So I get 180 minus 75, the answer is 105. So I get to know that this angle is 105 degrees. So what I'm left with is now angle DBC. Angle DBC would be equals to 180 degrees minus 48 degrees minus 105 degrees. The reason being that these are angles on a straight line. So I get 180 minus 105 minus 48. 27 degrees is the answer I get here. Coming towards question number 2, taken from May, June 2021 paper. P, Q, and R are points on the circumference of a circle center O. Can be seen on the diagram as well. Angle POQ equals 8x degrees. So it's not really given to us, it's given to us in the terms of x. Angle RPO equals x degrees again, not known. And angle OQR equals 24 degrees. So this is the only angle that's completely known to us. So we have to figure out angle PQO, PQ and O. This angle right here. All right, first thing first, since the center is labeled, by the way, whenever you have the center labeled, first always try to figure out the radii or diameter or whatever would be applicable on the circle, because that makes things very easy for you and that would help you to quickly identify what properties could you be applying in the question. So what I can see is that OP and OQ are the radii. So this length would be equals to this length. And hence this tells me that triangle OPQ would be an isosceles triangle. So these base angles would be same. So if I try to figure out what these base angles would be, obviously I won't be able to figure out the exact value of it, since the center angle is given in the terms of x. So, but that's fine, I can at least find the value in terms of x. So for angle PQO, it would be 180 degrees minus 8x degrees over 2. The reason I get this expression is that this is isosceles triangle. To simplify it further from the numerator, I could be applying a bit of algebra here. I could be taking 2 common, so this leaves me with, let's bring the equals to sign down. Okay, 90 degrees minus 4x degrees. The reason I have done this is so that this 2 in the denominator could be cancelled with it, and hence I'm just left with 90 degrees minus 4x degrees. So I know my this angle right here is 90 degrees minus 4x degrees, and likewise this angle is also 90 degrees minus 4x degrees. So if I now get to know the value of x, I would be able to figure out these two angles. I guess this quite is not my answer. I really need one absolute, not absolute, exact, one exact answer for it. So for that, I still need to do some working. What I know already is that in this question, there's only this one angle that's completely known to me, and this is the only number that I could be using for my working. So I need to figure out a way of, because right now in this triangle POQ, this angle does not really, I mean, this is not part of this triangle. So I have to include this angle somewhere in my working. For that, what I'm going to do now is instead of PQO, I'm now going to look at triangle PRQ, because that would help me bring in this angle right here in my working. So if I have to figure out this angle, if I'm looking at this triangle, I now know this whole angle in terms of x, that would be x degrees plus 90 degrees minus 4x degrees. I now know this whole angle, that would be 24 degrees plus 90 degrees minus 4x degrees. I do not though know this angle. So let's see if I can figure out this angle in some way. This is the angle made on the circumference, and it's by the way made by the chord PQ, this chord or the arc PQ, and this same arc or chord is making this angle 8x degrees at the center. This means angle PRQ would be equals to 8x degrees divided by 2. Why? Because angle at center is twice the angle at circumference. So this would be 4x degrees. So now I know this is 4x degrees. So I now know all the three angles in this triangle. So what I can now do is I can apply, and since I know all the three angles of this triangle, and I know that angle sum of triangle is 180 degrees. So when I add them, 4x degrees plus this whole angle, that's x degrees plus 90 degrees minus 4x degrees plus this whole angle, that's 24 degrees plus 90 degrees minus 4x degrees, I should be getting 180 degrees because this is the angle sum of a triangle. So let's simplify this expression. This is 180 degrees equals 4x degrees minus 4x degrees and minus 4x degrees. So this and this gets cancelled, but I'm left with this x degrees minus 4x degrees, that would be minus 3x degrees. And I have 90 degrees plus 90 degrees, that's 180. So 180 plus 24 is 204. So I get plus 204 degrees. So now I could be taking 204 on that side. So 180 degrees minus 204 degrees equals minus 3x degrees. So 204 minus 180 is 24 degrees. So I have 24 degrees equals minus 24 degrees equals minus 3x degrees. So x degrees would be equals to 24 divided by 3, that's 8 degrees. So the value of x is 8, that means this would be 8. But what I was asked to find was EQO. EQO, this angle right here that I figured out the expression of in the very beginning. So let's just substitute the value of x that we just figured out into this expression and find the answer, final answer. So that would be 90 minus 4 times 8. So 90 degrees minus 32 degrees, that would be equals to 58 degrees. That's my final answer. Number 3 now. ABC are points on the circumference of a circle center O. OBD is a straight line, and angle ABD equals 130 degrees. Find angle ACB, giving a reason for each step of your working. So let's see, where is this angle ACB? ACB is right here. Okay, so first thing like I explained earlier, this is O. Let's first figure out where your radii would be. This would be the radius, this would be the radius, and hence equal. So this angle would be equals to this angle. We can very easily work out this angle, one of these angles, and how exactly ABD is a straight line. So 130 degrees is given. So if I subtract this from 180, I'll get to know what this angle would be. And same would be this angle. The reason why I'm talking about these two angles is that to figure out this ACB, if I get to know this angle at the center, I know the angle at the circumference is half the angle at the center. So it would be really easy for me to figure it out then. So let's just find angle ABO first. So angle ABO would be equals to 180 degrees minus 130 degrees. And the reason for this is angles on a straight line. So this would be 50 degrees. So this is 50 degrees, that means this is also 50 degrees. So now I'm looking at, let's change the color first. Again, now I'm looking at triangle AOB, and I know that it is an isosceles triangle. So if I figure out angle AOB now, that would be equals to 180 degrees minus 50 degrees minus 50 degrees, reason angle sum of triangle. So 180 minus 100 would be 80 degrees. That means this right here is 80 degrees. And now the last thing that I really had to find was angle ACB. So it would be 80 degrees divided with 2. The reason angle at center is twice the angle at circumference. So this would be 40 degrees. And that's it. Coming towards the B part of question number 3, B part says that we have to, okay, P and Q are points on the circumference of a circle, a different circle, center O. PR and QR are tangents to the circle at P and Q respectively, and OP equals 8 centimeter and angle POQ equals 130 degrees. Find PR. So PR length is what we need to figure out here. This length right here. By the way, if PR is a tangent and QR as well, so we could be making this tangent kite here. And what we know about tangent kite is that this length is equals to this length. This length is obviously equals to this length because these are the radii. And this line that I've drawn in the middle, it bisects this angle at the center. So this 130 is now divided into 2. So if I divide 130 into 2, this is now 65 degrees. And likewise, the angle below this is 65 degrees as well. And this is a 90 degrees angle because OP is the radius, and angle between the radius and the tangent is always 90 degrees. So we had to figure out length PR, this length. This is a right angle triangle that I'm looking at. So triangle OPR is a right angle triangle. Okay. And in this triangle, if I have to figure out the length, I know in right angle triangles I can either use trigonometric ratios or Pythagorean theorem. Since for Pythagorean theorem I need to know those lengths, but I just know one length here, that's 8 centimeter. I do not know the other. So therefore I'm sticking to trigonometric ratios here. For trigonometric ratios here, this angle 65 degrees is given. Let's name the sides looking at this angle. This would be my adjacent side. This is hypotenuse OR, does not given, neither required. And PR is my opposite side. So adjacent and opposite side, that means I'm going to use tan ratio here. So tan of 65 degrees would be equals to opposite is PR over adjacent is 8. So this means PR equals to 8 times tan of 65 degrees. Let's see what the answer is. 8 tan 65. The answer is 17.15, so I can say it's 17.2 centimeter. That's it. Question solved. Okay, so question number 4 says A, B, and C lie on a circle. The line BPQ is a tangent to the circle at B. OCQ is a straight line. Okay, and BQO equals 36 degrees, BAC equals x degrees, so we have to find the value of x. So we can see all of this labeled here. So first of all, again, we see this is a radius, this is a radius right here. Let's change the color first. So these two are the radii, and as mentioned, A, B, Q, and as can be seen as well, this is a tangent, and we know that tangent and radius, they always make a 90 degrees, a right angle. So now if you notice, this OBQ is a triangle, right angled triangle. So, and in this triangle, we have this 36 degrees given. We have figured out this, there it would be 90 degrees. So let's work this angle out. So angle BOQ, wait a second, okay. Angle BOQ would be equals to 180 degrees minus 90 degrees minus 36 degrees. That would be equals to 54 degrees. So that means the center angle is 54 degrees. We had to find angle X, which is right here. Again, note that this angle X is being made by the same arc that's making this 54 degrees angle at the center, and the arc I'm talking about is BC, this arc. The same as the arc is making both of these angles, one at the center, one at the circumference. So that should make you think about the property that angle at the center is twice the angle at the circumference. This means x degrees would be equals to 54 over 2, that is 27 degrees. Why? Because that was the angle at center is twice the angle at circumference. There you go. Question number 5. Points A, B, and C are on the circle. AOC and OBE are straight lines. DE is a tangent to the circle at C. ABO angle equals 34 degrees. First part, we have to explain why triangle AOB is isosceles triangle. Pretty simple. We have the center labeled. OA and OB would be isosceles. So since OA and OB are the radii of the circle, this circle, and hence equal in length, therefore triangle OAB is an isosceles triangle. That's that. You may write it down however you want to. My writing is pretty messy. I think I better just erase it. Too embarrassing to keep looking at it. Okay. Next, what we have is we have to find BEC. BEC, that's this angle. Okay. So we are just given this 34 degrees angle, nothing else. Okay, so if this is 34 degrees, this would also be 34 degrees because it's an isosceles triangle. We already have figured that out. And if that's the case, this angle at the center, that is angle AOB, would be equals to 180 degrees take away 34 degrees take away 34 degrees. Why? Because they are angles in a triangle. The answer that it would give me is 112 degrees. So this is 112 degrees. Now with this 112 degrees, I can find this angle as well. I mean, if I have to find angle EOC, that would be 180 degrees minus 112 degrees. Why? Because these are angles on a straight line. So if I subtract this, I would get 68 degrees. So this right here is 68 degrees. The reason why I found this angle is because what I have to find out this is this E angle right here, and this lies in a triangle OEC or OCE, whatever, triangle OCE. And if I'm interested in this triangle, if I could be thinking about choosing the angles on a triangle, I need to know at least two angles here. So I have figured out the 68 degrees. About this angle, that's at C, this is the angle between a tangent, that's DCE tangent, and radius, that's OC. And the angle that's between radius and a tangent, it's always 90 degrees. So this is right angle. Now that makes things pretty easy now. So angle BEC would be equals to 180 degrees, take away 90 degrees, take away 68 degrees, and you get the answer. So 90 minus 68, we get 22 degrees. Final answer. Next up, we have question number 6. PQ, RS, and T are points on the circumference of a circle. Center OP is Q equals 32 degrees and O lies on TQ. PS is parallel to QR and QR equals RS. Okay, all of this is shown in the figure 2. We have to first find PQT, this angle right here, and we have to give the reasons for each step. Before coming towards this angle, again we see that the center has been labeled. So let's look if we have radii or diameter given. So this dq, you can see this is the diameter, and for the diameter we know that every angle that a diameter makes on the circumference, it should be 90 degrees. So this is 90 degrees. This is 90 degrees as well. Okay. First looking at triangle PQT, because this angle PQT is in this triangle. Okay, so this is 90 degrees. If we only figure out this angle T. Now for this angle T, if you notice, this angle is being made by the chord PQ, and the same chord PQ is making this angle 32 degrees at S. So every angle that is being made by this chord should be equal. So this angle would be 32 degrees as well. So let's just write it down. Angle PTQ would be equals to 32 degrees. The reason for this is that it's angle made by same arc. Likewise, angle TPQ would be equals to 90 degrees. Why? Because that is the angle in a semicircle, or angle made by diameter, however you want to write it. Alright, so now angle PQT would be equals to 180 degrees, take away 90 degrees, take away 32 degrees, and the reason for that is angle sum triangle. So 90 minus 32 58 degrees would be the answer. This is 58 degrees. That's right, clearly. 58 degrees. The answer of this. Okay, moving on to the second part, we have to find QRS. QR and S, this angle. Now for this angle, we know this is isosceles triangle. This angle would be equals to this angle. How do we find this angle? They have told us that PS is parallel to QR. These are parallel lines, and this right here, this QS, is a transversal. You can see that this is Z angle forming. This right here. So if this is 32, this would be 32 degrees as well. So doing the second part here, angle SQR would be equals to 32 degrees. Why? Because these are alternate angles. Then if this is 32, this would be 32 degrees as well. Angle QSR would be equals to 32 degrees too, because it's isosceles triangle. This means angle angle QRS would be equals to 180 degrees. Take away 32. Take away 32. The reason being that they have angles in triangle. So 180 minus 32 minus 32, the answer is 116 degrees. That's how you do the second part. Now next we have TQS. Okay. For TQS, let's take a nicer color maybe. Let's take this. TQS. This angle right here. Okay, so TQS, now that is pretty easy, not too hard. If you notice that this S, P, Q, and R, they're all lying on the circumference. So P, Q, R, S is a cyclic quadrilateral. This means that the opposite angles would add up to 180 degrees. So this whole and this whole should be equals to 180 degrees. That means angle PQR would be equals to 180 degrees minus 32 plus 32. Where did I get this 32 from? These two angles added up. This 180 minus this would be this whole angle. So 180 minus 32 minus 32, we already have figured this out. This would be 116 degrees. So this means this whole is 116 degrees. Now we were not interested in this whole angle. However, we were just interested in this small portion of it. So let's find angle TQS. That would be from this whole 116 degrees. Take away the angles that we already have labeled there. That's 58 and 32. Minus 58 degrees minus 32 degrees. And the answer would be minus 58 minus 32, 26 degrees. Okay, so we have question 7 next. In the diagram, AC is a diameter of the circle center, or the tangents from T touch circle at B and C, BCD equals 62 degrees, all labeled on the diagram. We have to find x degrees, that's here. Now that's very easy. This is a radius, this is a radius, this is a radius. Angle between radius and tangent is always 90 degrees, so this would be 90 degrees. It's complete. So x degrees would be equals to 90 degrees. Take away 62 degrees and the answer would be 28 degrees. All right, after that we have to find y degrees, which is here. Okay, so if this is 62 degrees, because this makes an isosceles triangle, if this is 62 degrees, this would be 62 degrees as well. So y degrees would be equals to 180 degrees minus 62 minus 62 degrees, because it's angle sum of triangle, and 180 minus 62 minus 62, the answer is 56 degrees. Final answer. Question number 8 now. Angle AOB is 48 degrees, DEB is 54 degrees. Everything given on the diagram, we have to find x. So first of all, the center is given. Let's label the radii, this, and this. They would be all equal. Now, if this is angle, I'm looking at triangle AOB. So because it's isosceles triangle, if this is x degrees, this would be x degrees as well. So if I have to find x, it would be 180 degrees minus 48 degrees over 2. That would be my x. So this would be 180 minus 48 is 132 divided by 2. The answer is 66 degrees. Triangle AOB, I applied angle sum of triangle because it was isosceles triangle, so the base angles were both equal. So I subtracted 48 from 180 divided by 2. I got what this one angle would be equals to. Next we have to find y degrees. It's right here. Now this is angle at center and it's been made by chord DB or BD, and this same chord is making this 54 degrees on the circumference. So applying the property that angle at center is twice the angle on circumference, so y degrees would be equals to 2 times 54 degrees. Why? Because angle at center is twice the angle on the circumference. So 54 times 2, the answer is 108 degrees. Next up we have to find z degrees this. Let's see if this is part of any cyclic quadrilateral. This is on the circumference, this vertex is on the circumference, this is on the circumference, and this right here is on the circumference as well. Cyclic quadrilateral. So we have B, C, D, E is a cyclic quadrilateral. So z degrees would be equals to 180 degrees minus 54 degrees. Why? Because in cyclic quadrilateral, the opposite angles, they are supplementary, or they add up to 180 degrees. So the answer would be 126 degrees. Here you go, we have got all three answers right here. Question number 9, in the diagram, the circles with center O and Q touch at P, where OPQ is a straight line. The line ORT intersects the smaller circle at R and is a tangent to the large larger circle at T. OR equals 4 centimeter, RT equals 6 centimeter. The radius of the larger circle is X centimeter. Now, if you look at it, it seems like a very complicated thing, but it isn't quite really that complicated. We just have to figure out a couple of things here. Now, first thing first, we have two circles. Let's look at them separately. So this is a center. This means this OR and OP would be the radii, and since OR is 4, so OP would be 4 as well. Likewise, moving on to the bigger circle, we have Q as the center, QT is the radius, that's X, and hence QP is the radius as well, so this would be X2. Now, this OT line or RT line is actually a tangent to this bigger circle. So this tangent is making an angle with this radius. And we know that this angle is always a right angle, 90 degrees. So let's mark that to here. This would be 90 degrees because it's the angle between the radius, that's QT, and I'll just write it down here. Angle RTQ would be equals to 90 degrees. Why? Because it's angle between radius जो कि है QT and tangent, that is RT. Okay. Next up, we have to work out the value of X. We do not have any other angle given, but what we can see is now that we have a right angle triangle, and the triangle I'm looking at is OQT. It's a right angle triangle. So in a right angle triangle, whenever we have to figure out length, we could either be using trigonometric ratios, but for that we need to be given one other angle in the triangle. But if we are not given that, we use Pythagoras theorem. So over here we are going to use Pythagorean theorem. For that, OQ squared would be equals to OT squared plus TQ squared. This is what the Pythagoras theorem would look like if we apply it over here. So OQ is 4 plus, because OQ is this whole length from here till here, OP is 4, and from OP onwards, let's use a different color, from P to Q, this is X. So complete length over here would be 4 plus X. So 4 plus X whole squared would be equals to OT, that is this whole length here. Now this is 4 plus 6, that's 10. So 10 squared plus TQ. Now TQ is this whole length, and that is simply X squared. Let's open up the squares here. Okay. So 4 plus X squared, for expanding this bracket, this is A plus B whole squared form. We are going to use identity, the first identity. If anyone doesn't remember that identity, it was A plus B whole squared should be equals to A squared plus 2AB plus B squared. Okay, so this would be 16, because 4 squared is 16, plus 2 times 4 times X plus x squared equals 100 plus x squared. Moving on, we get 16 plus 8x plus x squared equals 100 plus x squared. Because we have to find the value of x, let's group the like terms. So maybe I'm keeping 16 plus 8x over here first and taking x squared over there. So 100 plus x squared minus x squared, they cancel, and we are left with 16 plus 8x equals 100. So let's take 16 there now. 8x would be equals to 100 minus 16. So now we have 100 minus 16. The answer is 84, and 84 divided by 8, the answer would be 10.5. This right here is your answer. I should erase it from here. 10.5. Okay, that's it. Okay, the final answer, nice, neat, and clean. Let me just go through this question once more. She has done. See, it looked complicated, but it wasn't really that hard. You just had to look through things, that's it. Okay, question number 10. A, B, C, and D are points on the circle center O. BAD equals 68 degrees and CBO equals 52 degrees. We have to find CDO. Okay. So starting off, first of all, we do not really see, I mean, we can calculate this angle here. That would be angle BOD equals 2 times angle 68 degrees, because it's the angle at center that's made by the same arc that's making angle 68 degrees at A. So 68 times 2, you get 136. So this whole angle is 136. Now, we know this is the radius, this is the radius. If we had any isosceles triangle, we would have, sorry, if we had any triangles made, we would have known that they would have been isosceles. However, if we do not have any triangles made, we do not have, we cannot apply, and the angle that we are concerned with is this bit here, and CDOB is not a cyclic quadrilateral. We can't even apply that identity of that property of opposite angles being supplementary here. So what we could be doing instead is, although they have not given us triangles, but what if we make a line here and make a triangle of our own? So now this is a radius as well, and we have got now two isosceles triangles. This would be 52 degrees as well, and if these two are 52 degrees, we can work at this angle right here. So let's look at that first. So triangle CBO, angle BOC would be equals to 180 degrees minus 52 degrees minus 52 degrees. The reason being angle some triangle. So we get 180, take away 52, take away 52, we get 76 degrees. So this is 76 degrees. This whole that I have marked with red was um, this whole was 136 degrees. So if I subtract 76 from 136, I would get this angle. That would be angle C. Basically, this is now in triangle COD. So angle COD would be equals to 136 degrees minus 76 degrees, and the answer is 60. Alright, so if this is 60 degrees, now this actually, you don't really need to do any working for that, because if one angle in a triangle is 60 degrees, that's understood that the rest of the two angles would also be 60 degrees, because all the three angles they have to add up to 180 degrees. So this would be 60 degrees as well, and this would be 60 degrees as well. This means that this is an equilateral triangle. However, if you cannot think of this thing, then again, this angle would be equals to this angle, because it's an isosceles triangle. We have OD and OC as radii. So you can apply that method of 180 degrees, take away 60 degrees, and divide by 2. You would still get 60 degrees as your answer, whatever feels okay to you. So angle CDO is what we were concerned with. So we have figured that out, that it would be 60 degrees because angle sum of triangle. So angle CDO equals 60 degrees. That's our answer. Okay, so A, B, C, D, and E lie on the circumference of a circle center O. Tangent AF touches the circle at A. O is the midpoint of AD, and DOE equals 138 degrees and BEO equals 12 degrees. So before getting onto the paths, first let's see if we have this center identified. So what else do we know? We know this would be the radius, this would be the radius, this would be the radius, hence all equal. AD is the diameter, hence this angle B would be 90 degrees, because this is the angle made in the circumference, or angle made by the diameter. Furthermore, if this angle is 138 degrees, we can work out this angle. So I'm first just trying to work out angle EOA equals to 180 degrees minus 138 degrees. The reason being they are angles on straight line. So this tells me that 180 minus 138 is 42 degrees. So I also know this angle. ठीक है. Okay, so coming to the parts, I have to find EAD. E, A, and D, that's in the color, this angle. Now I know this is isosceles triangle. These two are already marked. These are the radii. This 42 degrees angle I just figured out. So pretty easy it is now. So angle EAD would be equals to 180 degrees. Take away 42 degrees. By the way, if these sides are equal, these angles would be same as well. So I'm just finding the sum of both and dividing with 2. So 180 minus 42 is 138, divided by 2, you get 69 degrees. So 69 degrees is the answer. This right here is 69 degrees. By the way, this complete is 69 degrees. So if I have to work out only, let's say, this bit of it, this would be 69 minus 12, and the answer would be 57. Though this isn't required, I just did that for no reason. Next, I have to find EAF. EAF, which is this triangle, this angle right here. Now, this is the radius OA, I know that, and this AF is the tangent. So, angle between radius and tangent is always 90 degrees. So, this would be 90 degrees. So if I take away 69 from 90, I would get this angle EAF. So angle EAF equals 90 minus 69. The answer is 21 degrees. Okay, that's done as well. Next, we have to find angle BEA. Let's see where this angle is hidden. BEA. This, oh, we already have that figured out. So how did I find this angle? BEA was equals to 69 degrees minus 12 degrees, and the answer was 57 degrees. Wow, the answer is already there. Let's just write the answer of this as well. Over here, that was 21 degrees. Okay, next we have to find BCD angle. Angle BCD, this right here. Okay, so for this angle, since there are no equilateral isosceles triangles or so, but I do see this is on circumference, this is on circumference, this is on circumference, this is on circumference. So we have a cyclic quadrilateral. So what I have observed now is that BCDA is cyclic quadrilateral. Now, if I have this figured out, by the way, I should write it ABCD. ABCD. That means this angle C and this angle right here, they would be supplementary angles. If only I know this angle. So let's try to think of the ways of figuring this angle out. Now, this angle lies in the triangle A, B, D. In this triangle, I know this angle, that it's 90, but if only I knew this angle. So see if this angle could be found in any way. This angle is being made by the chord AB, and the same chord AB is making this angle right here. And angles that are made by same chord, they are all equal. So if that angle is 57 degrees, this angle would be 57 degrees as well, because they are coming from the same chord. So what I have now figured out is angle ADB would be 57 degrees. The reason for this is angles made by same chord. All right. Now since it was triangle ABD, if I have two angles figured of this triangle, I can find at the third angle, that is angle BAD would be equals to 180 degrees, take away 90, take away 57 degrees, and the answer would be 33 degrees. So this right here is 33 degrees. By the way, we are not done yet, because this is not what we were interested in. We had to find this angle. And the reason we found this angle is so that we could apply the property of cyclic quadrilateral and say that this angle and this angle, they are supplementary. So now angle BCD would be equals to 180 degrees take away 33 degrees. Why? Because it's cyclic quadrilateral. So the answer would be 147. Right here. So that's it. Done with this one. 2. Question number 12. In the diagram ABCDE lie on the circle center O, the points B, O, and E lie on a straight line. AB is parallel to AD and DEO equals 53 degrees. So before getting on to the work, let's just see what we can figure out. This is center. So this, and this, they would be all radii. So this angle would be 53 degrees, though not given. Though not required, but I'm just writing down. Maybe it would be needed later on. This angle would be 90 degrees because it's been made by the diameter, that's BE. Furthermore, parallel lines are given. This is parallel to this, and we do see that we have a Z angle forming right here. Very nice and neat. This is the Z angle forming. So if this is 53 degrees, this would be 53 degrees as well because they are alternate angles. So if we have 53, Z is 53, 90 degrees given, we can work out D as well. So 180 minus 90 minus 53. So 180 minus 90 minus 53, that would be 37 degrees. We have so much stuff done already. Let's see the question and go sequence wise. Find x. We have to figure out x that we haven't yet done. Alright, so x is the center, angle at the center. So let's just see that where is it coming from? It's coming from all the way here, B point, and all the way down there, D point. So it's coming from this arc BD. Let's make it very clear. This BCD, this arc. Let's try to see if any other angle in this whole diagram is coming from these two same origins, B and D. So B line I see is getting extended till here, and D line is coming here as well, and this angle is 53 degrees. So that means angle at the center is twice the angle at the circumference property could be applied because both of these angles are coming from the same arc, that's BCD. So x degrees would be equals to 53 degrees times 2. Why? Because they are angle at center. It is angle at center. Okay, 53 times 2. 106 degrees. This is your x right there. Next, we are asking you to find y. Okay, so for y, we see a cyclic quadrilateral. You see, we see that this right here is on the vertex. This is on the this right here is on the circumference. This is on the circumference. This and this, they are all on the circumference. So B C D E is cyclic quadrilateral. This means angle y and this should add up to 180 degrees. So this means angle y degrees would be equals to 180 degrees. Take away 53 degrees. And the answer would be 127 degrees. Okay, so Z angle, let's just write these down, 127 degrees. Okay, Z angle is what we have to figure out now. Z angle right here, we already have that worked out. How did we work it out? We considered that this is a Z angle because A, B, and D, E, they are parallel lines. So Z degrees would be equals to 53 degrees. Why? Because these are alternate angles. As simple as that, no working required. So 53 degrees is the answer of C. Coming towards D, now for D, for looking at triangle A, B, E, and we said that angle BAE would be 90 degrees because it's angle made by diameter, and therefore angle T would be equals to, or only T basically. T would be equals to 180, take away 90, take away 53. The answer is 37 degrees. Okay, there you go. 4 parts done. Next up, we have question number 13. In the diagram, ABCD and E lie on the circle center O. ACB equals 69 degrees and DCA equals 34 degrees. Find ABD, find AOD, and find DAB. First of all, two angles are given to us. So ACD is 34 degrees, that's given right here. Now this 34 degrees is coming from the chord A and D. So let's just first figure out what other angle would be equals to 34 degrees. What other angle is coming from um, the same chord. So from these 2 points, the other angle that we see forming up is the angle right here. Sorry for a really crooked line. Okay, so this would be 34 degrees as well. Why? Because there are angles coming from the same chord. So in the first part, we had to find ABD, A, B, and D. So this is our ABD figured out already. So ABD would be equals to 34 degrees. The reason being angles made by same chord or arc, whatever you want to write. Next, we have to find AOD, A, O, and D. So this is the center, sorry, this is the angle at center, and we know that angle at center is twice the angle at the circumference made by the same arc. So let's just figure out if which chord or which arc is making this angle at the center. This is again the same chord, AD, and see if it is making any angle on the circumference. Yes, it is. Right here at C, 34 degrees, and this here at B, 34 degrees. So AOD would be 2 times 34. Why? Because this is angle at center. So it would be twice. So the answer is going to be 68 degrees. Next, we have to find DAB. D, A, and B. So this would be this angle right here. This whole angle is what we have to find. This DAB, if you look closely, this lies in this triangle that I'm marking with red. This and this. Oh, very crooked line. For some reason, I am unable to make a nice straight line. Okay, not too bad. Okay, so this triangle DAB is what I'm looking at. Triangle ADB, DAB, whatever you want to call it. So this is the angle we are interested in, and in this triangle we already know this angle B, that's 34 degrees. So if only we figure out this angle right here as well, we would be able to apply the angle sum of triangle. So let's try and see if we can figure out this angle that's been made at D. Now this angle that's being made at D, this is coming from the chord AD. Let's use this green color. Okay, this is coming from this chord AD. So first let's just see if this chord AB is making any other angle on the circumference. So it is making this angle right here, that's 69 degrees. So this is 69 degrees, that means this would be 69 degrees as well. Okay, now we can apply the angle sum of triangle. So angle DAB it is. Angle DAB would be equal to 180 degrees minus 69 degrees plus 34 degrees, and the reason being angle sum of triangle. So 69 plus 34 would be 103, and 180 minus 103 would be 77 degrees. So the answer is 77 degrees. Question number 14 says the points P, Q, R, and S lie on the circumference of a circle. PQR is a trapezium with PQ parallel to SR. T is the point on SR such that QPT equals 66 degrees, Q2TR equals 35 degrees, and TQR equals 79 degrees. Find PTS, giving a reason for your answer. And this is how the answer has to be written. So PTS is this angle right here that we have to figure out. Now if you see, they have already told us that RS is parallel to PQ, and if you look closely we can see a Z angle forming here. That means this would be equals to this angle, so it would be 66 degrees. So PTS is 66 degrees, the reason being that these are alternate angles. Next up we have to find PTQ. PTQ is this angle right here. Oh, pretty simple. These are the three angles on a straight line, so their sum must be equals to 180 degrees. So if we subtract 66 plus 35 from 180 degrees, we'll get the PTQ angle. And the reason being that these are angles on a straight line. 66 plus 35 would be 101, and 180 to take away 101 would be 79 degrees. That's your answer.